Well, sorry for the interruption. So going back to this example 1b, seeing how you have x squared minus 4, difference of square, you can factor this difference of square to x minus 2 and x plus 2. And by solving this equation, you will have your x minus 2 giving us this answer. And you will have x plus 2 here giving us this answer here. Now for those of you who are not too sure how to come up with the value of x from the step here, from the line here, don't worry about it. We're going to spend one entire class to talk about the way to solve a quadratic equation algebraically. But today we are focusing on solving quadratic function using a graph. Now of course most of the time we will use a graphing calculator to solve these equations. So moving on to the last one, example 1c. Seeing how we don't have any x-intercept for this parabola, we have no roots for this quadratic equation. So once again, using the parabola for a quadratic function, we can then identify the zeros or the x value for your quadratic equation. Moving on to the example number 2. Solve each equation by graphing. This time they did not give us the graph. But given we have our graphing calculator, I will still be able to solve this equation by join the parabola with a graphing calculator, and then we go from there. So here with x squared minus 9x plus 8, if I'm to draw the parabola of this quadratic function, I will see this parabola going across the x-axis somewhere. And the x-intercept on your parabola would then be the zeros, would then be the answer or the root for your equation. So here, let me graph it. Well, my graphing calculator doesn't have a proper window. Let me zoom it back to standard. So here is a parabola, and by just looking at the screen, it seems like I have x equals 1 here, and I have x equals 8. But if you want to double check, if you want to make sure they are actually at x equals 1 and x equals 8, I can use my graphing calculator to identify the x-intercept on this parabola. If I go second and calculate, I can use 0 to find the x-intercept. Here is one of the x-intercept. I'm going to use this method to find each of the x-intercept one by one. Your calculator doesn't give us both zeros at the same time, so we need to repeat the process again once we are done with this point. So here, pick a point on the left hand side, pick a point on the right hand side, and we can find the zeros in the middle. That gives us x equals 1. And I can do the same method again, use the same method, and find the x-intercept on the right hand side on my parabola. Second and calculate. Find the zeros, and I will move my cursor to the right hand side. Pick a point on the left of 0 and pick a point on the right of 0, and here I want to find the 0 in the middle. And yes, we do have x equals 8. So if you have a graphing calculator, you can solve a quadratic equation like this by using your graphing calculator. Enter your equation here as y1, and as you draw it out, you will see a parabola that opens this way. And let me just make a quick sketch. I will see my parabola having x-intercept at 1 and 8, and this parabola will open up this way, giving us the root at x equals 1 and x equals 8. So the whole point is to, well, to make it easy, basically we will just use the graphing calculator, enter the equation into y1 and solve it. We want to have our equation written in this way, like a trinomial. If they don't have an equation written in a trinomial, we can rearrange the term and rewrite it as 4x squared plus 23x plus 33. What I've done here is to group all the terms to the same side. You can move the 4x squared to the left and make the right hand side as 0. It doesn't matter. It will still give us the same result. So 4x squared plus 23x plus 33. As we move these two terms to the right hand side, we will come up with a quadratic function, or quadratic functions for now. Draw it out on the graphing calculator, enter the equation 4x squared plus 23x plus 33 and graph it. We see a parabola. Well, it seems like it is touching -3, but I'm not too sure. What you can do is to zoom in using your graphing calculator. As I press zoom and then in, I can now move my cursor to the point where I want to zoom in and press enter. Now you see how this parabola goes a little bit below the x-axis before it goes back up again. So if I can take a look at the little box here, if I can take a look at this particular region here, I will be able to identify the 0. So I'm going to create a box on my calculator. Under zoom, I have option number 1, zoom box. Press enter. And I can pick one point on this graph to start my box. Press enter to select your first point, and you move your cursor to create a box. And now you see 2 zeros. These 2 points here will give us the answer for x here. And I can use second calculate to find the 0 on my parabola. By choosing a point on the left and on the right, I will be able to find the 0 in the middle. -3. Yes, indeed, we do have a root at -3. But there is another one here. Second, calculate zeros again. You need to repeat the process for the other 0. Your calculator wouldn't give us the both x-intercept in one single step. The x-intercept, you need to do it twice. So here we have -2.75. And this happens when we drew our parabola and we saw how this parabola just go under the x-axis, giving us the zeros here and there. And we have -3 for one answer and -2.75 for the other one.